Shri Gurubhyo Namaha children, welcome to our online teaching academy Ekalaiva. Today I am going to discuss a new concept as mathematical induction. Mathematical induction. Mathematical induction. First of all, I want to tell you what is mathematical induction. Mathematical induction is nothing but one of the techniques which can be used to prove variety of mathematical statement which are formulated in terms of n, where n is a positive integer. What I said? Anyone? Okay, once again I am going to repeat the statement. You have to listen carefully. Mathematical induction is nothing but one of the techniques which can be used to prove variety of mathematical statements which are formulated in terms of n. First step, that is initial step, you have to prove for n equal to 1. Then the next step, that is inductivity step, is you have to assume the result is true for n equal to k. The third step, you are going to prove the result is true for n equal to k plus 1. Already it is formulated, you are going to test it. That's it, mathematical induction. For that, exercise 2.5, question number 1. What it is? Question number 1. 1 cube plus 2 cube plus 3 cube plus etc. plus n cube equal to n square into n plus 1 the whole square divided by 4 for all n belongs to capital N. First step, what I said, this is our P of N, right? This is our P of N. Let P of N denote the statement P of N. You have to denote the statement. What statement? What it exists in the left side, that is 1 square plus 2 square, 1 cube plus 2 cube plus etc. plus n cube equal to n square into n plus 1 the whole square divided by 4. First step, this is your P of n. Now put n equal to 1. And what can you get in the left side? The left side, 1 cube. When you come to the right side, this is your left side. Then you come to the right side. Right? N can be replaced by 1 square. 1 plus 1, the whole square, divided by 4. This is equal to 1 into 4 divided by 4 equal to 1. Now your LHS equal to RHS. 1 cube is nothing but 1. Right? 1 cube is nothing but 1. This is your RHS. LHS equal to, then RHS equal to. Therefore, LHS equal to RHS. First step, you want to prove the result is true for n equal to 1. Then you should conclude P of 1 is true. First step I said you have to prove the result is true for n equal to 1. Next step, the inductivity step I said, right? In that you have to assume the result is true for n equal to k. Let step 2. Let us assume the result is true true for n equal to k. So P of k, that is 1 cube plus 2 cube plus etc. plus k cube equal to k square into k plus 1 the whole square, the whole thing divided by 4. The whole thing divided by 4. Step 3, you want to prove the result is true for n equal to k plus 1. Right? Now, n equal to k plus 1 you want to prove. To prove P of k plus 1 is true. Now, the LHS equal to 1 cube plus 2 cube plus 3 cube plus etc. plus k cube plus k plus 1 the whole cube. Your n can be replaced by k plus 1. The previous term is k cube. Then it can be replaced by, this is your equation number 1. See here 1 cube plus 2 cube plus 3 cube plus k cube equal to k square into k plus 1 the whole square by 4. So the curly bracket I drew, that can be replaced by k square into k plus 1 the whole square divided by 4 plus k plus 1 the whole cube. Then you have to take LCM. Or you can take which is common, k plus 1 the whole square is common in both the terms. So k plus 1 the whole square you should take it as a common. The rest of the thing k square by 4 plus k plus 1. Now which is equal to k plus 1 the whole square, k square plus 4k plus 4 divided by 4. The numerator can be replaced by the identity, that is k plus 2 the whole square, k plus 1 the whole square into k plus 2 the whole square divided by 4. This is your LHS. Then you have to go for your RHS. Here n can be replaced by k plus 1. So k plus 1 the whole square, n square into n plus 1 the whole square. So n can be replaced by k plus 1 the whole square divided by 4, which is equal to k plus 1 the whole square, k plus 2 the whole square, the whole thing divided by 4. What you have arrived in LHS, the same thing you got it in the RHS. Therefore, LHS equal to RHS. Then P of k plus 1 is true whenever P of k is true. Therefore, by the principle of mathematical induction, P of n is true for all n belongs to capital N. It is true for natural numbers, right? Now, question number 2. Question number 2. 1 into 2 plus 2 into 3 plus etc. n into n plus 1 equal to n into n plus 1 into n plus 2 divided by 3 for all n belongs to capital N. Here also the same. Let P of n denote the statement. That means what it exists in the left side. Denote the statement. First you want to prove for n equal to 1. Second step you have to assume the result is true for n equal to k. Third step you want to prove the result is true for n equal to k plus 1. Right? Step 1. Put n equal to 1. Then what can you get in the LHS? 1 into 2 which is equal to 2. RHS. RHS equal to 1 into 2 into 3 divided by 3. In the place of n, you substituted 1 in LHS and the RHS. LHS equal to RHS. Therefore, P of 1 is true. First step, you want to prove the result is true for n equal to 1. Therefore, P of 1 is true. Second step, you are assuming that the result is true for n equal to k. Let us assume the result is true for n equal to k. Then how it will act? 1 into 2 plus 2 into 3 plus etc. plus k into k plus 1 equal to k into k plus 1 into k plus 2 divided by 3. This is my equation number 1 that I am going to substitute in step 3. Step 2 is always useful to replace, right, in the step 3. Step 2 is useful to replace what it exists in the left side of step 3. What it is? To prove P of k plus 1 is true. To prove P of k plus 1 is true. LHS 1 into 2 plus 2 into 3 plus etc. plus k into k plus 1 plus k plus 1 into k plus 2. N can be replaced by k plus 1. I told you the step 2 is useful to replace the LHS of your step 3. That is, the curly bracket can be replaced by k into k plus 1 into k plus 2 divided by 3 plus k plus 1 into k plus 2. In both the things, which is common? K plus 1 into k plus 2 is common, which is equal to, if you want you write by 1, which is equal to k plus 1 into k plus 2, k plus 1 into k plus 2 bracket k by 3 plus 1, which is equal to k plus 1 into k plus 2 into k plus 3 divided by 3. Now you pass on to the RHS, the general P of n. That is n into n plus 1 into n plus 2. Here n can be replaced by k plus 1. So k plus 1 into k plus 1 plus 1, k plus 1 plus 2. The whole thing divided by 3, which is equal to k plus 1, k plus 2 into k plus 3, the whole thing divided by 3. What we have arrived in the LHS, the same thing we got it in the RHS. Therefore, LHS equal to RHS. That means P of k plus 1 is true. P of k plus 1 is true whenever P of k is true. Whenever P of k is true. Therefore, by the principle of mathematical induction, P of n is true for all n belongs to capital N. Again, I am going to say the steps alone, right? Step 1, you are proving the result as n equal to 1, right? See here, step 1, first step, you are proving the result is true for n equal to 1. Next step, you are assuming that the result is true for n equal to k. Third step, you are going to prove the result is true for n equal to k plus 1. Right? First and third you are going to prove. Third one, second one you are assuming. Right? First and third you are proving. Second one is assuming. Using the second one only, we are proving the third step. Right? Thank you, children.